Okay, all right. So, today we're going over chapter 4 review. Fun times. Everybody loves the math, right? Yeah. All right. So this chapter 4 was the systems chapter, basically. Okay, we're doing systems of equations and systems of inequalities. What are the 3 ways to solve a system? Graphing, substitution, elimination. Okay. 1 and 2 says, what is the solution of the system? Use a graph. So we are going to graph them. I think I have them already. Maybe I don't. I thought I already wrote it. Okay. Well, never mind. I'll just have to do it right here, I guess. So for 1 and 2, 2 is set up the way it needs to be. Number 1, though, you need to solve both of those for what? Solve them for y first. So I'm going to put 1 over here. We'll say negative 3x plus 4y equals 2. And then I'm going to the left of it, or right of it, I'm going to put the other one because we need room to work. Okay, and if you need to do this on a separate sheet of paper, please do. What will we move first on the negative 3x plus 4y equals 2? The 3x. So we're going to add 3x over. 4y equals 3x plus 2. And then you divide everything by 4. So y equals 3/4 x plus 1/2. And then we do the same thing for the other equation. So we remove our x, add x over. 2y equals x plus 2. Divide by 2. Y is 1/2 x plus 1. Everybody clear to that part? All right, beautiful. And then we graph those. So this is where you want your graph. Yes, I physically want you to graph them. So I'll try to draw my best graph here. Oh, change colors. So my first equation that I solved, what is my y-intercept? 1/2. So that's not too bad to graph, but we are pretty much guesstimating, okay? So it's right there, halfway up, okay? And then what's my slope? 3/4. So I rise 3 and run 4. So up 1, 2, 3, and over 1, 2, 3, and 4. So about right there. Where else could I go? Could go down 3, 1, 2, 3, and left 1, 2, 3, 4. So I could, that is an option. All right, and then we connect the dots. Now the problem with doing this freehand is I'm not sure my points are going to line up. If you have graph paper, they should line up, okay? On my second one, where is my y-intercept? 1. So right here. And I go up 1 over 2. Would be about right there. So, or I could go down 1, left 2, and graph it as best I can. All right.
They're supposed to have lined up at that point you put.
Yeah, I see that right here.
Yes, sir.
So what am I mess up on? Or am I just a bad drawer?
I think it was just the graph.
It probably is. Here, I'll try to make it look better. Oh, shoot. All right, so we had this one, right? What is it supposed to go through? 2, 2, supposed to go through right here? So we'll just use that one. How about that? Boom. Ta-da. So there's my answer, okay? Everybody listen very closely. I want the graph. I see the graph. Don't forget to tell me the answer, okay? I can't tell you how many times people have done this test and they just graph it and they even circle where they're crossing everything, but they never say the answer. What is the answer? 2, 2, okay? So make sure you tell me after you graph it, you come over here and say, hey, you know, my answer is 2, 2. Yes, ma'am.
Is it okay if we get the graph counting by 1/2?
Sure. If you want to count by 1/2, yes. Yes, that's fine. Okay. All right. Number 2. 2 is already set up for us. So it's much easier to work. And really, I guess technically you could have worked it without graphing it, but it told us to graph it, so we're going to graph it. What's my y-intercepts on the first one?
2.
2. So 2, my slope is 5. So up 1, 2, 3, 4, 5. I'll just add another one up there and over 1. So there's 1 graph. What was the other y-intercept? -2. And its slope is 5 as well. So 1, 2, 3, 4, 5 over 1. And those lines are what? Parallel. So when they're parallel, the answer is no solution. So don't forget to write your answer. No solution. Okay? Any questions on those first 2? Everybody's good? All right. 3 and 4, you're doing the same thing, but you get to use your graphing utility, aka calculator. So I'm going to change screens so we can see the graphing calculator. And we basically plug it in. What's my first one?
Y equals
2x plus 7.
2x plus 7. And the second one? -3x minus 2. And then you hit what? Graph. And there they are. And then it looks like -2, 3, but I'm not sure. So I'm going to do what to make sure? What do I hit? Second, trace, and I want their intersection. So you can scroll down to 5, or you can literally just hit the number 5 button. And you have to hit enter 1, 2, 3 times, and it will tell you the intersection is -1.8 and 3.4. Everybody understand how to do that? Okay? And you do the same thing for number 4. Did we have to solve those first? Nope, they're ready to go, aren't they? So clear that one out. Number 4, we have -1/2 x plus 3. And then for the second one, we have 6x minus 5. And we hit graph. And again, same process, second, trace. We want their intersection, number 5, enter, enter, enter. 1.2307692 and 2.3846154. Let's just round to 2 decimal places, okay? So never mind, let's round to 3 decimal places then. Their way is always better. So that would be 1.231 and 2.385. Okay, they both get rounded up. Everybody good on 1, 2, 3, and 4? Everybody's got the graphing part down. Remember, I don't mind if you use your calculator to check 1 and 2, but I do want to see your graphs on your, like I said, you'll have an answer sheet that goes with it, and you can plug it in. Everybody good? Wonderful. All right, go back to my other screen. All right. So starting at number 5, we get to use what? Substitution. So make sure you use substitution, okay? Any other time you're taking a test and you get a system problem, you can do it whatever way you want to, okay? But since we're studying substitution and elimination, they want you to do it a certain way sometimes, okay? So I'm going to substitute negative 3x plus 11, because remember, you don't use substitution when you know y equals or x equals something, right? So I'm going to substitute that in for y in the other equation and write it out. So we'll have 3x plus 2 times 3x, or excuse me, negative 3x plus 11 equals 7. That'll do everything right? All right. Distribute your 2. You get 3x minus 6x plus 22 equals 7. Subtract 22 from both sides. What is 3x minus 6x?
Negative 3x.
Negative 3x equals negative, is that 15?
Yes, sir.
And then we divide by negative 3. X equals 5. And then what do we do to get y? Plug it in. So y equals negative 3 times 5 plus 11. Negative 3 times 5 is negative 15 plus 11 would be negative 4. So your answer is 5, negative 4. Here, I'll just write out here. Try that one more time. 5, negative 4. Okay. Any questions? Everybody's good? Wonderful. I don't have any room. Is it okay if I erase that and start over? Okay. All right. 6. 6 is interesting because you have y equals and y equals. So if you had your graphing calculator, I would probably graph it. But again, the directions say use substitution. So it does not matter which one you put where. I'm just going to take the top one right here and plug it into y in the bottom. So we'll have 3x plus 6 equals 2x. And we subtract 3x. 6 is negative x. We don't want negative x, do we? We want positive x. So x is negative 6. And then what do I do to get y? Plug it in. Y equals 2 times negative 6 would be negative 12. So negative 6, forgot the negative again. Negative 6, negative 12 would be the answer for number 6. Everybody good? Moving right along. Number 7. Need an edit button. 7, I'm going to take, again, the top, what y is, plug it in for y in the other equation. So we're going to have negative 3x minus 5 plus 5 equals negative 3x. Okay? And, well, what's negative 5 plus 5? 0. So we end up with negative 3x equals negative 3x. And if you ever end up with exactly the same thing on both sides, what's your answer? Infinite solutions. Okay? Done. Don't have to work anymore because it's infinite solutions. Everybody good?
Yes.
All right. Awesome. Moving right along. 8, 9. How are we supposed to solve them? Elimination. So this time, these two. Sorry, I gave you 3 substitution and 2 elimination. That doesn't seem fair, does it? I'm sorry. You like elimination? You don't?
Yes.
You don't like elimination?
I like elimination.
All right. So to do elimination, we're going to add them up, right? And we need something to what? Cancel. The x's or the y's to eliminate. So before we do that, we need them to be the same number, but one's positive and one's negative. All right. So we can get rid of x or y. I'm going to choose in number 8. I'm going to get rid of the x's first. Here's why. No matter which way I do it, I got to multiply both equations by something. Okay. And the x's are already, one's negative and one's positive. Okay, so that's really the only reason I'm picking the x's here. It doesn't matter though. So again, this is the way I always do it. Okay, it might get big numbers sometimes, but it works every time. That's a -5, below it's a 3. I'm going to take the 3 and multiply that on the top, and take the 5 and multiply that on the bottom. And we're multiplying the entire equation. Okay, so 3 times -5x is -15x. 3 times 7y is 21y. And 3 times -27 is -81. Okay, is that right? Is that -81?
Yes, sir.
Okay, I was making sure. All right, on the bottom, 5 times 3x is 15x. 5 times 9y is 45y. And 5 times 3 is 15. Now we can add them up. That's 66. Y equals -66. And so we divide by 66. Y is -1. And what do we do with that to get x? So even if you miss substitution, you always get to do it last anyway. Okay? So substitute -y in for either one of the equations. It does not matter. I want to do the bottom one because the numbers seem to be a little bit smaller. 3x plus 9 times -1 equals 3. That will be -9, right? Oops, I can't write up there. So 3x minus 9 equals 3. Add 9 over. 3x is 12. And divide by 3. X is 4. Any questions? So our answer is 4, -1. Okay? Everybody good? Or did I mess up? I messed up earlier. I didn't like it. Didn't like it at all. All right. For number 9, you want to get rid of the x, or do you want to get rid of y? Y. Y, again, does it matter? It doesn't, but y is easier because I only got to multiply one equation by a number rather than multiplying both equations by a number, okay? So I want to multiply this top equation. If on the bottom I have 16y, what do I need on top? -16y. So what times 4y would give me -16y? -4. So I'm going to distribute the -4 to everything. -12x minus 16y equals +28. Okay. Don't let the negatives catch you. All right. And then on the bottom, we got, I'm going to write it above it. Is that okay? Because I need room. Okay. So I moved this up there. Okay. Add them up. The y's cancel. -8x equals 40. And divide that by -8. So x is -5. Plug it in to get your y. I want to plug it into the top one. 3 times -5 plus 4y equals -7. So that's -45.
You put 15, -15.
Oh, I sure did. My bad. I was just having a good day. I told you I messed up earlier and didn't like it. That's what it is. So -15. Sorry about that. I'm glad y'all are here to keep me straight. Plus 15, 4y equals 8. Divide by 4. Y is 2. All right. In the immortal words of Sheldon Cooper, easy peasy. Huh? Everybody good? All right. So the rest of your problems, because your honors, are word problems. But you get to solve this system however you want to. Okay? What's wrong? I messed up? Oh, easy word problems. Exactly. All right. So 10, I need room to do 10. All right, I'm gonna write 10 down here below 11 because that's the only place I got room for, okay? So it says Tom has a collection of 21 CDs and Nita has a collection of 14 CDs. Tom is adding 3 CDs a month to his collection while Nita is adding 4 CDs a month to her collection. Find the number of months after which they will have the same number of CDs. So obviously we're gonna have to make how many equations? 2. We've got who are the 2 people that have CDs? Tom and Anita. So Tom has how many to begin with? 21. And he's gaining how many per day? Or per month, excuse me. So 3M for month. All right. Nita, she's got how many to start off with? 14, but she's gaining 4 a month. Okay. What do I do to figure out how many months they got to do to have the same number? I need Tom and Nita to have the same number, right? So they need to what? Equal. And now you just substitute. Tom's is 21 plus 3M. And Nita's is 14 plus 4M.
Is it okay to skip the whole first part you did?
Yes.
Your whole T.
Yes, you just went straight here? Yeah, that's fine. I'm just trying to make sure everybody understands how we're getting there. Because not everybody, it just doesn't, not everybody sees it like that, okay? So, once you get there, now it's just a regular problem, right? So I subtract 3M, subtract 3M, subtract 14, and subtract 14. After 7 long months, they will have the same number of CDs, okay?
I just did,
Everybody good?
I just did 21 plus 3 plus 3 plus 3, and then 14 plus 4 plus 4.
You just kept going and, all right, that's the long way, and it works, but try to do it that way. It's much quicker, all right? 11. This time we got what we were dealing with. Baked goods, right? Cakes and pies, okay? All right, cakes and pies. So that is our 2 variables, cakes and pies. It says they sell 2 kinds of baked goods, cakes and pies. A cake costs $5 and a pie costs $7. In one day, the store sold 12 baked goods for a total of $68. How many cakes did they sell? Okay, first off, how many baked goods did they sell total? 12. So that's all the cakes plus all the pies will be equal to 12. All right. Now, how much money did we make? $68. Well, each cake costs $5, so you get $5 per cake plus how much per pie? $7 per pie, and that's going to equal to 68. Okay, and like I said, you can do substitution if you would like. I'm going to do elimination because it's set up to do elimination. Okay, notice if you want to figure out how many cakes did they sell, you're going to get rid of the what? The pies. Okay, so I'm trying to save you a step here because if you solve for pie, if you get rid of cakes first and solve for p, now you got to plug it back in. If you just go ahead and get the cakes first, you don't have to plug it back in. Is that making sense? Okay. So I've had some people before, they actually solved for the wrong thing, thinking they were getting it right. And so they were doing everything right, but the answer wasn't answering the question. Okay. So I need to get rid of the p. So I'm going to multiply the top by -7. So -7c minus 7p equals -84. And then here we got 5c plus 7p equals 68. Add them up. The p's cancel. -2c equals Is that 16? Is that right?
16.
Okay. Divide by -2. We got to sell 8 cakes. Okay.
So that's how many they did sell.
Correct. Well, that's okay. They sold 8 cakes. Everybody good?
Yes, sir.
Page 1. Everybody clear? Awesome. All right. Page 2. More word problems. Woo! I knew. I love. Yay math. Yay math. Exactly right. All right. So number 12. I'll put it over here. All right. Again, the half of the battle is figuring out what are your 2 variables here. All right. Page Turner Bookstore sells how many kinds of books? 2. That's probably your 2 variables. Okay. They sell hardcover and paperback. A hardcover book costs $13 and a paperback book costs $9. In one day, the store sold 13 books for a total of 145. How many hardcover books did they sell? Okay. So this problem, we just did it. The only difference is last problem we were talking about cakes and pies. This time we're talking about hardcover books and paperbacks. Okay. But everything else is the same. How many books total did we sell? 13. So that's hardcover plus paperback equals 13. And how much money did we make? Or did we? Yeah. Did we buy, I guess? $145. So each hardcover book was 13 plus each paperback was 9 equals 145. And they want us to know how many what? Hardcover books. So which one are we going to get rid of? The P. We want to get rid of the P. All right. So we're going to multiply this top one by -9. All right. I'm going to put the answer down below it here. So that'll be -9H minus 9P. I need your help. What's -9 times 13?
-117.
-117. Add them up. That will be 4H. The P's cancel. Equals, let's see here, that'd be 28. Is that right? Divide by 4. There are 7 hardcover books. Okay? Everybody good? Awesome. All right, can y'all? I don't know if I'm trying to see if it'll scoot over for me. Oh, well. 13, I guess I'll just have to erase. All right. 13. What are we selling on 13?
Vegetarian.
Wraps. 2 kinds of wraps. You got vegetarian and chicken. The vegetarian wrap cost $1 and the chicken wrap cost $1.30. Today they made $173.70 from 147 wraps sold. How many of the wraps sold were vegetarian? Any difference in this problem besides what we're talking about? No. Say 3 in a row. Same thing. Okay. So we've got vegetarian wraps plus chicken wraps equals how many wraps did we sell total? 147. How much was each vegetarian wrap? $1. Each chicken wrap was $1.30 equals how much money? 173.7. I sure did. Thank you. C. Don't forget the variable. That just looks ugly and it bothers me. Okay. They want to know how many wraps of sold were what? Vegetarian. So I'm going to need to get rid of C. So multiply everything by what? -1.3. All right. So -1.3 V minus 1.3 C equals negative. I need your help.
191.1.
Negative 191.1. Thank you, ma'am. All right. The C's cancel. I'm left with negative 0.3 V equals negative 17 point what? 0.4. And we divide that by negative 0.3. And all these decimals are making me crazy. But what's our final answer?
58.
58. That's better.
I did the long way. Cancel out the long variables.
It's okay if you do it. Just know you're making your life a little longer than it has to be. Okay? Or I said your life. You're making the problem a little longer than it has to be. All right. Everybody good on 13? Awesome. All right. 58 vegetarians. That's a lot of vegetarian wraps. I guess.
Dad, lady vegetarian. She brought like tofu chicken nuggets.
Awesome, Eleni.
Actually, not bad. I tried it. Not bad. It'll be okay. I tried it. It's not bad. I tried it.
Okay. Shifting gears here. Okay. Not quite the same now. It says Mike and Kim invest $9,000 in equipment to print yearbooks for schools. Each yearbook costs $6 to print and sells for $30. How many yearbooks must they sell before their business breaks even? So we have for 14, is that right, 14? All right, so we have our costs and we have our income, and we need the cost and the income to what? Equal. That's how you break even. Okay, you have all your cost has to equal all your income. All right, so my cost, how much does it cost? We got $9,000 in equipment. Okay, each yearbook costs $6 to print, so we also have to add to that $9,000 $6 per book. Okay, any other costs? No. Our income is how much we're selling for. So how much are we intaking every time we sell one? $30. So 30 times B. And then I just set those two things what? Equal to each other. So 30 times B equals 9,000 plus 6B. And you subtract 6B from both sides. 24B equals 9,000. 9,000 divided by 24 is how many books you sold, and you should get 375.
I skipped the whole.
Okay, you can. Sometimes problems that are system, like you really don't have to. This one really you need to figure out, okay, how much are we making off of each book? Okay, so you're doing the same thing. You're just doing the 30 minus 6 in your head to begin with. Is that making sense? Some people can do that. Some people can't. It's all right either way. All right? Everybody good?
Yes, sir.
Last one, 15, very similar. This time we're at the ballpark, right? All right, so we got concessions and equipment and all kind of stuff. And we're trying to break even because we don't want to lose money because we can only have 25% of our fans show up because of COVID. And it's all a big blah. All right. So at the local ballpark, the team charges $4 for each ticket and expects to make $1,300 in concessions. The team must pay its players $600 and pay all other workers $1,900. Each fan gets a free bat that costs the team $2 per bat. How many tickets must be sold to break even? So our costs. Let's think about our costs. How much does it cost us to do this? So it costs us, we got to pay our players how much? $600. We got to pay our concession stand workers or every other worker how much? $1,900. And it cost us how much per bat? $2 per bat. So plus $2 per bat. Our income is how much are the tickets? $4 per ticket, okay? Plus $1,300. in concessions. Okay, now we have a little bit of pickle here. We have a B here and a T here. Now, how are they getting a bat? They're getting a ticket. So tickets and bat, the number of tickets and the number of bats are the same. Okay, so just figure out which one you want which to be. I'm just going to change that B to a T. Does everybody understand why we can do that? Because the only way to get a bat is if you bought a ticket. Everybody with me? And now we set those equal to each other. I'm going to, as I'm setting them equal to each other, simplify a little bit on that top one, okay? 600 plus 1900 is 2500. So I'm going to change that to 2t plus 2500. And then we work our little algebra problem out. So we get 2t, subtract 1300 from both sides. We get 1200. So we're hoping, we're praying that we get at least 600 people to come. Okay? Yeah, that's before we make money. That's just not losing money.
Majors, they pay
That's
a ton of money every game.
Yeah, that's not really majors. That's more like a minor league probably game.
At a local ballpark.
Local. Yeah. Unless you live in Atlanta, that could then you know. All right, everybody good on 15? All right, 16 through the rest of them, we start talking about our inequalities. Okay. That sure is a lot of work for all 1 through 15, but the rest of these, they don't have much work. Okay, so I'm just going to erase a little bit here just so I have room to write the answer. It gives you the line. You can't see the shade very good on my copy, so I'm going to shade it in here for you just so everybody's clear what's being shaded. So what you start with, you're going to say y equals, was it shaded above the line or below the line? Below, so I know it's going to be less than. Is it a solid line or a dotted line? It's solid, so that makes it equal, all right? And then we got to figure out my slope and my y-intercept. So my slope, if I go from there to there, let me change colors. I don't know if that'll matter. From there to there, I go down what? 1, 2, 3, right? 1. So 3 over 1 is 3. And it's negative because it's going down. So I guess I need to change negative 3x. And then where did it cross the x-axis? Or I mean the y-axis. 1, 2, 3, 4 at positive 4. That is it. That's all you have to do. All right? Everybody good with that? Know how to do it step by step. Awesome. 17, it is shaded, again, I won't write it in here, shaded above. What kind of line do we have here? It's dotted, and it's just horizontal, right? So that means, are we going to have an X? No, it's just Y. Y is, we're shaded up or down? Up, so that's greater than, it's a dotted line, so we do not put equals. What is Y greater than? Negative 1. Done. Everybody good?
I actually got that one right.
All right. Moving on. 18, we're shaded again. Can't see it very good. You shade it over here on this side. So we're going to have Y up or down. Did we shade up or down? Up. So that's greater than. It's a dashed line, so you don't put equals. Let's see here. It looks like we're crossing there and to there. So what would my slope be? We go up 1, 2, 3, 4, 5. Right 1. So 5 over 1 is 5. It's going up, so it stays positive. And X. And then what's my y-intercept down here? Minus 3. Can't believe I gave y'all 3 of those. I'm too nice. All right. Everybody good?
I'd rather have more of those than more problems. You can take out all the ones with elimination and put these progression.
19. You can plug in. If you really want to get fancy, you could graph it and see which points are in the shaded part. Okay?
Just plug
You're funny.
Anyway, all right, so we'll just start with A. X, Y is 5, so let's see here. 5, where can I put it? 5 plus 1, is that supposed to be less than 4 times negative 1? That would be 6. Is 6 less than negative 4? No, so it ain't that answer. Okay? Here we go. 12 plus 1 is supposed to be less than 4 times negative 4. That's going to be 13 is less than negative 16. Is that true? No. 7 plus 1 is less than 4 times 2. Getting closer. 8 is less than 8. Is 8 less than 8? No. So I guess that's my answer, but I'm going to double check just because I'm that guy. Negative 2 plus 1 is less than 4 times 2, so that will be negative 1 is less than 8. Last time I checked, it is. Okay? All you're doing there is plugging them in and seeing which one makes it true. Everybody good? 20 and 21. Hey, I do have my graphs over here. I've already made them. I thought I did that earlier, but I didn't apparently. So 20 and 21. Oh, okay. I even wrote the problem. So here you are graphing the inequality. So where do I start at? Positive 2. So 1, 2. Make a dot. Where am I going to go from there? Down 6 over 1. So down 1, 2, 3, 4, 5, 6. And right 1. So there's another point. Do I use a solid line or a dotted line? Dashed line. Dashed line, dotted, however you want to say it. Okay. And do I shade up or down? Greater than means you go up. So I shade everything above the line right here. Even 20 staying above the line. How about that? 21. What's my Y intercept? Negative 1. So down here, I'm going to start. All right. That is below the line. We're going to rise how far? 3 and run 1. So up 1, 2, 3. Run 1. It is also a dashed line. And unfortunately, we shade below the line. It is not having a good day. Gotta remember to stay above the line. All right? Less than, shade down. Greater than, shade up. Everybody good? Awesome. 22. Back to our word problem. I think this is the last one. It says you have $38 to spend on music and movie downloads. Each album costs $10 and each movie download costs $11. Write and graph a linear inequality that represents this situation. Let X represent the number of albums and Y the number of movies. So is there any way to go and buy a negative number of albums or see a negative amount of movies? No. So for my graph, I'm only going to need the first quadrant, right? Okay. So before we get too far ahead of ourselves, what would this inequality be? How much do they cost? 38 total, but each album, right, is 10, so I'm going to say 10A, plus each movie is what? $11 for the movie download. That has to be, all we have is how much? $38. So can we spend more than $38? No, it's got to be less than or equal to 38. Okay? Now, it's kind of up to you what you want to make what. I'm just going to go in the order they gave them to us. I'm going to let the albums be my X, okay? So you may want to, put that. This is the albums. And up here is going to be the movies. Okay? And now remember, to draw a line, you just need 2 points. I am not going to solve this for M or anything. I'm just going to find the intercepts. Okay, remember we talked about this. On the albums axis down here, okay, M is always what? 0. Everywhere on the albums axis, the M is 0. So if I just pretend like it's not there, I'm left with 10A equals what? 10A is less than or equal to 38. And I can divide that by 10, and you get 3.8. That is your albums intercept, okay? So 1, 2, 3, almost to 4. So about right there would be 1 point. And then I do the same thing for the movies. I can let A be what? 0. So you cover it up, all right? Pretend like it's not there. 38 divided by 11, I believe, is like 3.5, 3 point something, okay? So 1, 2, 3, I'm going to put it about 3.5, somewhere close, okay? Remember, it's just a sketch, all right? And we do what with those dots? Connect them. Is it a solid connection or a dashed connection? Solid connection, okay? And on your graph, if you want to, you can just say, hey, this right here is 3.8, and this right here was 3 point, what did we say it was? 3.5, okay? And we're going to shade where? Below. Boom. So just basically shade everything below it. Notice, am I going down into the negative part? No, because they're really not on my domain. Okay? No, I probably wouldn't, but just know it's, I mean, it can't, you can't have negative, you can't buy negative amounts of music or movies, okay? Everybody good?
Yes.
All right, 23. We're back to doing the easy problems. We have to write the equation, okay? So it's just like the ones we did a minute ago, but how many are there? There's 2. So we're going to have 2 y's. All right, I'm going to do this one first. Everybody with me? All right, first off, it's solid, and it's shaded where? Below it. So that's less than or equal to. Its slope is, looks like up 1 over 1, right? So that's just 1x. And where does it cross?
-2.
Minus 2, negative 2. The other one is going this way. All right. So it is also shaded where? It's also shaded below. So it's also less than. It's also a solid line. So that'll be equal to. What's its slope? Well, let's see here. It's crossing there and there. So it does. It goes down 3 and over 1. So negative 3x. All right. And where is it crossing? Let's see. 1, 2, 3, 4, 5, 6. Where is that point? Negative 6. Done. Okay? All you had to do. Tell what are the inequalities. 24, you are graphing one more time. The last time. I'm just going to draw it over here. Oh, I have it. Oh, look at me. I love it when I'm prepared. It's already over here for me, okay? So for the top one, I'm going to start at 1, right? The y-intercept right here is 1. And from there, what's my slope? Up 3 over 1. And solid line or dotted? Solid. And am I shading above or below? You're shading below. Okay? I realize you have pencils, so just do kind of a light shade to start off with and see where the shades cross and then darken that part up really good. Okay? So this one, if you have highlighters, great. That's perfect. Yellow and blue make green. That's beautiful. Okay? Here, I need to move my x over first. So y is less than or equal to negative x minus 1. So where is this one starting? Negative 1, which will be about right there. And I'm going to go down 1, right 1. So it's looking this direction, and it's also a solid line, yes? And do I shade above or below it? Below it. Okay, so it's going to look like this. And like I said, if you're using highlighters, it's kind of already done for you. But if you're using a pencil, just go back in and make sure you shade really good everywhere the shades are crossing. Okay? Because technically, that's your answer, not these parts on the side here. Okay? But I'm not going to make you go back and erase them. Just make sure the darker part's your answer. Everybody good? Yes, ma'am.
Will you make us, or will you count if we don't shade under completely or no? Because I don't shade.
You don't do these parts?
I don't do those.
As long as you give me that, you're good. Yeah, that's fine. Some people it's hard. It was hard for me to just do that in my head. Okay? Everybody good?
Yes.
All right, last one. It's a doozy. It's not hard. It's not even long. It's just there's 4 of them. Okay? So, take them one at a time. Okay? I'm going to do this one first. Right here. Okay? I'll let it be red. All right? So this one's red. So we got Y. Oh, by the way, it's shaded where? Everything in the middle? Is that right? Okay. So know that. Y is this red line, is it shaded above or below? Below, so it's going to be less than. Is this line solid or? It's dotted, so it's just less than. What is my slope of this line? 1, so 1x. And it's crossing where? At 3, so plus 3. All right? We'll do the other one right here. We'll say that one's the green one. Okay, this one right here. So it's Y. It's also shaded where? Below, but it's a what kind of line? Solid line, right? So it's less than or equal to, what's its slope? Down 1, right 1. So it's actually negative 1x. And where is it crossing? Plus 3 as well. All right. I'm running out of colors. Blue, we'll let this one be the blue one right here. So Y is this one is going to be shaded where? Above it, so it's greater than.
Natalie Board, please come to the front office.
It's a solid line, so it'll be equal to, what's its slope? Positive 1 again, and it's crossing the y-axis at what? Negative 3. And then last but not least, see if I can find pink, just for you. Y. All right, this one's pink. Y is, let's see here, it's shading above, so it's greater than. It's a dotted line, so you just leave it greater than. What's its slope? Negative 1 again, so negative x, and it's also crossing at negative 3. Beautiful. Any questions? Yes, ma'am. Luckily, that doesn't matter. You know. All right. All right, let me stop recording.